Okay, so in problem 34, letter A, they're telling us that we have an x value of 150. We have a standard deviation of 4 minutes. And they're asking us for the probability that x is greater than 160. In this case, the only thing that we're going to use is we're going to use a formula for c-score, which is our x value minus mu divided by sigma. Okay, so we use the standardization process in this case in order for our number here to be suitable for using the table, because in our table that were given to us, the numbers that go through the table are way smaller than 160, so we really can't get the value of the probability. So we have to standardize in order to get a smaller number in order to get our actual probability. So in this case, so we have the probability that x is greater than 160. This will change to 1 minus the probability of x is less than 160. This is because in our standardization process, we can only use less than values, or more like variable, less than values. So we can't use greater than. So that's why we're gonna switch it to a less than value by subtracting it by 1 and just flipping the sign. So we have this already, and then we proceed to standardize using this formula that we have right here. So we have 1 minus probability of z, which changes. It was x before, but since we're standardizing, it's going to be changed to z. So we have now probability of z it's less than 160, minus 150 but divided by 4. This will give us 1 minus the probability of z is less than 2.5. If we look in our table and search through 2.5, it will tell us that 2.5 is the value of, the probability of 2.5 is 0.9938. And then we just subtract 1 minus 0.9938, and we get 0.0062, which is our answer, and the probability that x is greater than 160. Okay, so in letter B, we have the same values as we had before. So we have an x value of 150. We have a standard deviation of 4 minutes, and we're going to use the same formula of c-score for this problem. So I'm saying that this one's easier because in this one we don't have to change any type of signs that we had. As you've seen in the number in letter A, we had to change the sign of greater than to less than, but this one is already in less than for us, so we can go straight up to standardize. So we have our probability that x is less than 146. We proceed on standardizing using this formula. So we have our x value minus our mean divided by the standard deviation. So we have 146 minus 150, that is negative 4 divided by 4. So that will give us the probability that z, exactly, is the same. We change to z because when we standardize, our x value turns out to be our c-score now. So it's z is less than negative 1. So if you look in our table and you go to negative 1, it will give you the number 0.1587. So this is our answer. So the probability that x is less than 146 is 0.1587.
First, you need to look for your mean and your standard deviation in the problem. In this case, it's 150 and 4. Next, you need to find your c-score for each one of your probabilities. And here is the formula. Is your x minus your mean divided by your sigma. So we're going to write my x minus my mean divided by my sigma. You're going to plug it in the calculator, and it's going to give you minus 1/2. Next up, your next probability, 152 minus my mean divided by 4 equal, plug it in the calculator, and it's 1/2. You're going to translate this to your decimals. So it's minus 0.5 and 0.5. So what you're gonna do with these values is you're gonna look for them in your standard normal probabilities chart. And you're gonna look for negative 0.5 and it equals 0.3085. And next 0.5 that equals 0.6915. Here I reaccommodated my values for better understanding. So next, what you got to do according to the formula is you got to subtract the greatest value from the lowest value. So we're gonna put 0.6915 minus 0.3085. You're gonna plug it in the calculator and it's gonna give you 0.383. Now you're gonna multiply it times 100 and it equals 38.3%. So now you have the percent and the decimal in your answer.
So in this problem, we have these formulas, but we're going to use this one that is C equals to X minus M over sigma, that's the C square. So in the problem, we got that the exactly is 150, the mean is 150, and the standard deviation is 4. So it's going to be C equals 150 minus 150 over 4, and that equals to 0. Since the beginning of the problem, we know that the answer is going to be 0 because the exactly and the mean are the same. When they are the same, we know that it's going to be 0 because both go on top here as the formula says. So we know that it's going to be 0.